we did a piece of work because I'm quite active in the disinformation space, or anti-disinformation rather, just to be clear.
Yeah.
And network analysis has been useful in that regard. Like there's this phenomena known as donuts, where you have one or two nodes and then you have a big donut around them. That
Yep.
is a telltale sign that, there's some active promotion of some message going on, and it's centered on a few players, and then the network just spreads it out, which is
Nice.
odd, given like normal discourse, people throwing tweets at each other don't create these donuts,
That's
or they
right.
appear in smalls. So that has a mathematical fingerprint, and that
That's
and we
right.
use that to, in a way, judge whether there's some active influence operations going on Facebook or Twitter. So yeah, I mean, that could be the step towards getting our heads around this fake news phenomena, because
Exactly.
I deal with journalists. They're spooked, they're completely freaked out at how AI is, A, taking over the jobs, and B, beating them at the news game. And
Yeah.
strangely, I don't know if it's the same in the States, there's still this weird wall between journalists and tech. They kind of don't get along. And that's a
Yeah.
shame. Yeah, it's a good idea. It's a good thing we have
That's
this chat.
cool. Yeah, man, I'm with you. Like I look at some of the same type things, and the thing that I'm most interested in is really influence
Yeah.
and how things influence other things. So, like you were talking about, you do start to see these interesting patterns with like disinformation or artificial amplification and things like that. So very cool. But yeah, like getting back to the language thing,
Yeah.
K-core is useful to look at the actual core of a network. But if you wanted to look at the outer parts of a network to see if they were different than like human, you could look at K-corona instead of K-core, whereas like the corona looks at the outer edges. So if you looked at K-corona with a K of 0 or 1, then you would get a subgraph of only the outer edges, the outer parts of the network. But I don't know if that's a good idea. It might be a total
It's
trash
worth
idea.
it's worth testing. I mean, that's the cool part about data. The data will be the judge if it's worth it or not. But it's not a reason not to try it, right? Yeah.
There's a book I'm reading, and it just says that it's really about just clever questions
Yeah.
of nature. It's really about doing something clever to get your answer. And sometimes we don't think of a clever approach because we're thinking in lists. Like maybe if we are thinking networks, if we did understand this stuff better, then we would start asking better questions to unravel this. Because if you can measure it, you can detect it. And if you can detect it, then you can do something about it.
Yeah,
So
applications can be created. Okay. I'm really liking the vibe we're headed. If you don't mind, I want to dial it back to how did you develop kind of this intuition? I mean, you said you're an engineer, you're more in the practical stuff. I mean, certainly it's one thing after another. Can you recall how you started to develop kind of this intuition about how data works and obviously networks? I mean, what
yeah,
was your thought process?
yeah, for sure. Like engineering is always at the root of it, understanding how things work or building things so that they work in a way that you want them to work. So either you're making something work or you're understanding how something works. And there's always been some of it because of like the relational databases, like relational databases, an application will use a few tables. So there's always a relationship between one application and a few tables. And another application might be using a few other tables. So even the ER diagram is not the whole picture compared to how an application actually uses the database itself. And my work was in data operations, and I needed to understand how things work and how things fit together. And spreadsheets will never give you that answer. Spreadsheets can kind of tell you what somebody wrote down in a spreadsheet that they thought how things worked. But I was brought onto a team in 2015, and they asked me to do a very difficult server migration. They didn't tell me that a whole bunch of teams tried before me and failed. I had no idea how difficult it was going to be. But during that first process, I didn't know network science. And I came up with all of these different techniques to audit a server, to understand what code ran on it, and then in that code, what databases were referenced, and what tables were referenced, and so on and so on. And it was a whole lot to hold into my head. And I probably had dozens of text files and spreadsheets that I used to help me get through that server migration, because I had like 180 programs that ran on that one server. It was a complicated beast, not a one trick type thing. You know, it was very messy. And we managed to pull it off and do it perfectly. But it was a lot to hold into my head. And then somewhere between that first one and the second time I did it, I learned network science. So after I learned network science, I took some of the things that I learned from that first one and redid them using a graph. And the first thing I realized was that, oh my God, I don't have to hold any of this in my head. Like, that's a huge thing, which meant that I had no anxiety on migration day, because I already mapped out a graph. I can use that to query the server to know how things work and stuff like that. I'm veering off course, but it's basically, old methods were inadequate for complicated work, and graphs make short work of complicated work. So things like spreadsheets are garbage for server migrations. Things like graphs literally made me 10 times faster. What used to take me months, 3 months, right, can now be done in a week. So it used to take me about 2 weeks to even map out how a server would work, and just turn it into like a nested script calling type thing. But after the graph approach was figured out, I could dissect the server in about 1 day. So it was a huge increase all around, and our migrations never failed. So the first migration that we did, it took us about 13 months, I think. And then after that, we were knocking out server migration after server migration. We did 20 in a year. So we went from 1 a year to 20 in a year with 0 failures at all. And it's just one of those things, you know, once you learn a better way of doing things, you're never going to go back to the old way of doing things. You cannot possibly, you know. So